Hi-ho. So, as you can see, we're going to be talking about quadratic functions today. We're going to have a short overview of them because I'm not with you. Aren't you all sad? Okay. Let's talk about quadratics. I don't have my markers ready. Oh, right here. It's right here. Okay. Do you remember that day we talked about functions at large, right? So linear function, so these are the functions we've talked about so far. We've had linear, where y and x are sort of balanced with each other, and we've had absolute value, right? And we talked a little bit about absolute value and the idea of a vertex, and that's going to be big for quadratics today. So the basic idea of a quadratic is this balance of y being the square of x. And there are a lot of places to go with that, and there's a lot to know. And the more you can take information that you learn from these to here, the easier life will be for you. Okay? So we talked a lot about the vertex of an absolute value. Do you remember that? We had this y equals absolute value of x minus h plus k. Remember that? Well, the same thing applies for this. So we are going to plot this, and then we're going to talk about vertex, okay? So let's just plot y equals x. Let's go back old school to a table. That's how we started everything, right? So x and y. So -0, please. My brain gets ahead of my fingers sometimes. So these are just kind of our standard, like we're going to plot a line, right? Well, what is -2 squared? Because y is x squared. -2 squared is negative times a negative is a positive 4, right? -1 squared, 0 squared, 1 squared is 1, 2 squared is 4, okay? Now remember, these look like these, the absolute value did. Remember? Go back and look. But let's look at what our quadratic will look like. So maybe should I do my Zoom music? Yeah. Ding, 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 ding. We're going to go over here, and then we're going to zoom. Do, 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 do. Quadratic function. Okay. Hi. So let's plot this, okay? We're probably going to have to do some in-betweens, all right? So here's x, and here's y. I'm going to give it some little marks so we feel good about ourselves. Boom. Okay. Let's plot these. -2, so we start always here. -2, 4. 1, 2, 3, 4. -1, 1. 0, 0, 1, 1, 2, 4. Now, before you start thinking this is like a V, right, like the absolute value, because yes, we have symmetry, right? We have symmetry. Symmetry. It's a hallmark of both absolute value and quadratics. So that's why we're going to talk a lot about absolute value with quadratics when it comes to graphing them, okay? And the ideas, some of them. Although quadratics are more complicated, and in my humble opinion, more beautiful, okay? So, but before you start drawing a V to connect these dots, let's think about like the point -1/2 or 1/2, okay? What is 1/2 squared? Well, 1/2 squared is 1/2 times 1/2, which is 1 times 1 over 2 times 2. 1 times 1 is 1. 2 times 2 is 4. So 1/2 squared is actually 1/4. So when you go right in here, you're actually just this tiny, there's half and a fourth, okay? You're just really tiny in there. The closer you get in here, it starts out really tight before it goes up. Because let's think about 3. Can we think about 3? What is 3 squared? 9. 4, 5, 6, 7, 8, 9. Now suddenly we're way up here, and -3 the same, way up there. So it's not a V, it's a curve. You're going to find out how more later, okay? So this is the basic idea. Now let's do a couple of examples, all right? Let's remind ourselves what happens with the vertex. Okay, hello again. Hidely ho. We're going to see if my little pretend microphone works. Yeah, take that, Rachel and Jen. So I've added some more. Can we see on here? I think we can. Yeah. I've added, you can see we'll use my marker as a pointer. I've added more values because I'm using this equation now, and I don't know how much my vertex might shift. Maybe you remember how to find vertex for an absolute value, and you're going, Ms. Thompson, this looks very similar, and you're 100% correct. So if you already get this, you can skip ahead. If you need a refresher, let's watch, see what happens. -4. -4 minus 2, quantity squared. That is -6 squared. That is 36 plus 1, 37. I don't want to plot that, but you know. -2. -4 squared plus 1, which is 16, plus 1 is 17. I also don't want to plot that high, but we'll see what happens. -1 minus 2 squared plus 0 equals -3 squared plus 1, and that is 9, plus 1 is 10. I also don't want to have to plot that, but we'll see. 0 minus 2 squared plus 1 equals -2 squared plus 1, which is 4, plus 1 is 5. Now we're in the range I might want to plot with what I have, what I wrote for myself. 1 minus 2 squared plus 1 equals -1 squared. Well, that's just 2. -1 squared plus, so that whole thing is 2. 2 minus 2 quantity squared plus 1 equals 0. Four minus 2 quantity squared plus 1 equals 2 squared plus 1 equals 5. Hold up. Let me check 3. Should we check 3? Because do you notice? Here I'm seeing a symmetry. 0 and 4. 0 and 4 bounce over to 5. So somewhere in here, there's a symmetry. And I'm going to guess, since I have 0, 1, 2, but I skipped 3, I'm going to guess if I plug 3 in, what number do you think I'm going to get out? I think it's going to be 2. So let's plug 3 in. Let's slide it right in here. 3. 3 minus 2 squared plus 1 equals 1 squared plus 1 equals 2. We were right. I already knew that. So let's plot this, and let's remind ourselves the vertex, okay? Are we tight on our graph? Let's get on our graph. Ding, 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 ding. I know you love the theme music. Theme music. Ding, 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 ding. Zoom, zoom a doom. Zoom a doom a doom. All right. So you can't see the points anymore. Hopefully you know, did what you need to do. Okay. I'm not going to plot this, it's way too big. Or nor am I going to plot that, but I'm going to start with -1. I'm going to plot these. -1 and 10. -1, 10, 0, 5, 2, 3, 4, 5, 1, 2, that's what we found, 2, 1, 3, 2, 4, 5, I think I found my symmetric point, right? Okay, what do we call this? We call this the, remember, from absolute values? Vertex. Now what is this point right here? It is 2, 1. Do we remember from our vertex equation or our absolute value equations? Right? There's a reason it's the opposite sign of this because we want to know what makes this 0. 2 made this 0. I need to zoom in on that. Right? The value 2 made this part 0. And because it made it that part 0, we just had this hanger on, which was the 1. And that is how our vertex came about. Okay? So it made that 0. Do you see it there? The 2 made that part 0. And so we get out the 1. Let's go back up to our graph. So pretty. Okay? This is high tech, folks. So this is how it shifts our vertex. Everything in the way an absolute value would shift, whether it becomes wider or narrower, whether it flips over, it's all the same for this. This, shockingly enough, is called vertex form. We're going to talk about forms in a second. The next one we're going to talk about is standard form, for your sake. Okay, excellent. And scene. Oh, hi. How are you? Something else I wanted to make sure to mention. Wow, my head's big. I'm like a floating head. This is called, can you see this? Yeah, we're going to put it right over here. The axis of symmetry. That's an extra squiggle. The axis of symmetry, my floating head, is the place where everything is symmetric around, okay? This is really important because if you can find the axis of symmetry from an equation, which we're going to talk about in standard form, if you can find it from the equation, then you can plug, because what is the axis of symmetry in terms of your values? It is the x value of your vertex, okay? This is the line x equals 2. For the record, the axis of symmetry on quadratics, based on how we define functions, is always an x equals. It's always a vertical line and it's symmetric around, okay? Always, always. Let's get me off of a floating head. Do you see what I'm saying here? So, this is the line x equals 2. There's the vertex and axis of symmetry. Now, you can find these from standard form equations. And you can put this equation in standard form if you need to. But sometimes, like linear functions, you're given different versions. Sometimes you're given different versions, and you have to know what to do with what that line is. But the basis will always be this. It will always be this idea of this relationship fundamentally between y and x. X is squared. Y is equal to whatever x squared is, and that's what makes it curve. Okay? Cool.